3-pole breaker is not required when running a 12mm4 wire to feed multiple circuits for floor machines. National Electrical Code Section 210.4 does not apply in this specific scenario. This code section typically addresses branch circuits that are intended to supply a single receptacle outlet. The scenario describes a 12mm4 wire run that provides power to multiple outlets. Because the wiring supplies multiple outlets, a single-pole breaker is adequate. It is important to understand the specific requirements outlined in the National Electrical Code to ensure safe and compliant electrical installations. Let's delve into the specifics of why a 3-pole breaker is not necessary in this case and review the relevant sections of the NEC to provide clarity. The National Electrical Code, or NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It's updated every 3 years, reflecting advancements in technology and incorporating lessons learned from electrical incidents. Understanding and adhering to the NEC is critical for all electrical work, including wiring configurations for floor machines. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. The overcurrent device, such as a circuit breaker or fuse, is designed to protect the circuit from overloads and short circuits. When a fault occurs, the overcurrent device interrupts the flow of electricity, preventing damage to the wiring and equipment and reducing the risk of electrical fires. NEC Section 210.4 specifically addresses multi-wire branch circuits. A multi-wire branch circuit, as defined by the NEC, is a circuit consisting of 2 or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, and that is connected to the neutral or grounded conductor of the system. Multi-wire branch circuits are commonly used in residential and commercial buildings to supply 120 volts and 240 volts or 120 volts and 208 volts. These circuits can reduce the number of conductors required, saving on materials and labor costs. However, they also require careful attention to ensure proper safety and compliance. NEC 210.4 deals with general requirements. This section stipulates that multi-wire branch circuits must supply only line to neutral loads. This means that the loads connected to the circuit must be connected between one of the ungrounded conductors and the neutral conductor. Line-to-line loads, where the load is connected between 2 ungrounded conductors, are generally not permitted on multi-wire branch circuits, except under specific conditions outlined in the code. NEC 210.4b covers disconnect requirements. This section requires that all ungrounded conductors of a multi-wire branch circuit must be disconnected simultaneously by the branch circuit overcurrent device. This ensures that all hot conductors are energized at the same time, providing a safer environment for maintenance and repairs. This requirement is typically met by using a 2-pole or 3-pole circuit breaker that is designed to disconnect all ungrounded conductors simultaneously. NEC 210.4c pertains to identification. This section requires that multi-wire branch circuits be clearly identified at the point where they originate. This helps to prevent accidental disconnection of the neutral conductor, which can result in overvoltage on other circuits. The identification must be done in a manner that is readily visible and easily understood by qualified personnel. In the scenario described, the 12mm4 wire is used to feed multiple 120 volts outlets for floor machines. Since each outlet is supplied with 120 volts, and the 12mm4 wire feeds multiple outlets rather than a single one, NEC 210.4 does not apply. The requirement for a 3-pole breaker is therefore unnecessary. Each 120 volt circuit can be protected by a single pole breaker. A 12mm4 cable contains 4 conductors, typically consisting of 3 insulated current carrying conductors and 1 bare ground conductor. In this context, the 3 insulated conductors can be used to supply 3 separate 120 volt circuits, each protected by its own single pole breaker. The ground conductor provides a path for fault current to return to the source, helping to protect against electrical shock and equipment damage. Using a 12mm4 wire in this configuration allows for efficient distribution of power to multiple outlets while maintaining compliance with the NEC. To further clarify, let's consider some additional factors that may influence the selection of circuit breakers and wiring configurations. Firstly, the load calculation is essential. Before installing any electrical circuit, it is necessary to calculate the total load that the circuit will be expected to carry. This includes determining the amperage requirements of all the devices that will be connected to the circuit simultaneously. The load calculation will help determine the appropriate size of the circuit breaker and the wire gauge needed to safely carry the load. NEC Article 220 provides detailed instructions on how to perform load calculations for various types of occupancies. Secondly, consider the voltage drop. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently or fail prematurely. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to use larger conductors or shorten the length of the circuit. Thirdly, pay attention to conductor ampacity. Conductor ampacity is the maximum current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. NEC Table 310.15b16 provides ampacity ratings for various types of conductors. It is essential to select conductors with an ampacity rating that is sufficient to carry the calculated load, taking into account any applicable damping factors. Fourthly, think about grounding and bonding. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to return to the source, helping to protect against electrical shock. Bonding ensures that all metallic parts of the electrical system are electrically connected, providing a low impedance path for fault current. NEC Article 250 provides detailed requirements for grounding and bonding. Fifthly, consider overcurrent protection. Overcurrent protection, such as circuit breakers and fuses, is designed to protect electrical circuits from overload and short circuits. Circuit breakers are typically used in modern electrical systems because they can be easily reset after tripping. Fuses are a one-time overcurrent protection device that must be replaced after they blow. The size of the overcurrent protection device must be matched to the ampacity of the conductors it is protecting. Sixthly, think about the type of wiring method. The NEC recognizes various wiring methods, including rigid metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, and cable assemblies. The choice of wiring method depends on the application, the environment, and the local codes. Each wiring method has its own advantages and disadvantages in terms of cost, ease of installation, and protection against physical damage. Seventhly, consider the environment. The environment in which the electrical system is installed can have a significant impact on its performance and safety. For example, in damp or wet locations, it is necessary to use waterproof or weather-resistant equipment and wiring methods. In hazardous locations where flammable gases or dust may be present, it is necessary to use explosion-proof equipment and wiring methods. Eighthly, pay attention to the local codes and regulations. In addition to the NEC, local codes and regulations may impose additional requirements for electrical installations. It is essential to check with the local authorities to ensure compliance with all applicable codes and regulations. In summary, when using the 12V-4 wire to feed multiple 120 volts outlets for floor machines, a 3-pole breaker is not required. NEC 210.4 does not apply in this case because the wire is feeding multiple outlets rather than a single one. Each 120 volt circuit can be protected by a single pole breaker. It is essential to perform a load calculation, consider voltage drop, select conductors with appropriate ampacity, ensure proper grounding and bonding, provide overcurrent protection, choose the appropriate wiring method, and comply with all applicable codes and regulations.